In this video, I will talk about Wi-Fi and terrestrial radio channels. Wi-Fi is a form of the wireless LAN and is a short term for IEEE 802.11 wireless LAN. Wi-Fi is basically seen everywhere nowadays and can certainly provide a way to connect between wireless stations, access points, and to the internet with much more mobility than the traditional wired connections. Though there are different 802.11 standards, they have some traits in common. They use the same medium access protocol, trade in their transmission rate for greater distances, and use the same link layer frame structures. Despite their similarities, they also have important differences. 802.11 devices operate in the 2.4 GHz or the 5 GHz frequency range, where the former is an unlicensed frequency band that may require the devices to compete for frequency spectrums with 2.4 GHz phones and microwave ovens, and the latter has a shorter transmission distance for a given power level. This chart provides a list of different standards along with their frequency ranges and data rates. BSS, the abbreviation for Basic Service Sets, are the basic building blocks of the 802.11 architecture. It consists of one or more wireless stations along with a central base station called the access point, AP for short. APs are then connected to switches or routers, which then connects to the internet. When an AP is installed, a service set identifier, SSID, and a channel number is assigned to it. For an 802.11 standard that operates in the frequency range of 2.4 GHz to 2.4835 GHz, the range it operates in is divided into 11 partially overlapping channels. When a wireless station receives signals from two or more APs, each of these APs could be located in a different IP subnet and have been independently assigned a channel. Wireless devices would have to associate with one of the various APs in order to access the internet. In passive scanning schemes, APs periodically send out beacon frames, which are listened to by wireless devices. The wireless device then sends an association request frame to the selected AP, which is then responded by the association response frame sent from the AP. Wireless devices can also perform active scanning, sending probe request frames to all APs within a certain range, and is responded by probe response frames sent from the APs. Afterwards, the steps are pretty similar to that of passive scanning, with the wireless device sending an association request frame to the selected AP, which is then responded by the association response frame sent from the AP. Authentication may be required in order to create an association with a certain AP, and can be done by permitting access based on the device's MAC address or through usernames and passwords. 802.11 wireless LANs use a random access protocol known as Carrier Sense Multiple Access with Collision Avoidance, CSMACA. When a station in a wireless LAN sends a frame, the frame might not reach the destination intact due to reasons like decreasing signal strength, interference from other sources, and multipath propagation, which arises when portions of the electromagnetic wave arrive at the receiver taking different paths, resulting in the blurring of the received signal. Thus, the 802.11 MAC protocol uses link layer acknowledgements. When the destination receives a frame, it waits for a short period of time, the short interframe spacing SIFS, and sends back an acknowledged frame as shown to the left. If the transmitting station does not receive an acknowledged frame after a certain time, it retransmits the frame. And if after several tries, the acknowledged frame is still not received, the frame is discarded and the transmitting station gives up. In the 802.11 CSMACA protocol, the station that has a frame to transmit first senses to see if the channel is idle. If the channel is idle, then the channel waits for a short period of time, the distributed interframe space (DIFS), and transmits the frame afterwards. If the channel is not idle, a random backoff value is chosen. The station starts counting down from this value when the channel is sensed idle, and freezes the counter if the channel is sensed busy. The station transmits the frame and waits for an acknowledgement when the counter reaches 0. If the acknowledgement is received, the transmitting station knows that the frame has been successfully received. Otherwise, the station chooses another random backoff value from a larger interval. An 802.11 frame consists of numerous fields that are of specific use for wireless links. The payload field contains an IP datagram or an ARP packet that may be allowed to have a length up to 2,312 bytes. The 4-byte cyclic redundancy check (CRC) field is used so that the receiver can detect bit errors in the frame received. 4 address fields are used in the 802.11 frame, each holding a 6-byte MAC address. They contain the addresses of the wireless station that is used to receive the frame, the station that transmits the frame, the router interface that the subnet uses to connect to other subnets, and the 4th address is used when the APs forward frames to each other in ad hoc networks. The sequence number field is used so that the receiver can distinguish between newly transmitted frames and retransmission of previous frames. The duration field contains information of the duration time that is reserved for a channel, including the time that the transmitting station uses to send its data frame and the time to transmit an acknowledgement. Given a certain modulation technique, there is a trade-off between signal-to-noise ratios (SNR) and bit error rates (BER). Different modulation techniques offer different transmission rates. If a user is close to a base station, the SNR will be high, and the BER will be low. As the user moves away from the base station, however, the SNR will drop and the BER will become unacceptably high if the same modulation technique is applied. Thus, some 802.11 implementations have a rate adaptation capability that allows it to choose which modulation technique is more suitable for the current situation. If the 2 frames is sent in a row without receiving acknowledgement, it implies the BER might be too high, and a modulation technique with a lower transmission rate will be applied. On the other hand, if 10 frames in a row receives acknowledgement successfully, it will switch to a modulation technique with a higher transmission rate. 802.11 standards provides power management capabilities so that the circuitry can remain turned off most of the time. By setting the power transmission bit in the header of an 802.11 frame to 1, a node can inform the AP that it is going to sleep. The AP then knows not to send any frames to that node, and buffers the frames for later transmission. The node will wake up for a short time just before the AP sends the beacon frame. And if there are no buffer frames that were to be sent to the node, it can then go back to sleep. With an inter-beacon time of 100 milliseconds, a wake-up time of 250 microseconds, and an also relatively small amount of time used to receive the beacon frame and to make sure there are no buffer frames, a node can remain asleep for 99% of the time and can save a significant amount of energy. Lastly, after saying so much about Wi-Fi, let's talk about the physical medium these signals are transferred through. Signals are carried in electromagnetic spectrums for terrestrial radio channels. The fact that no physical wire will need to be installed, the ability to pass through obstacles, and the capability of carrying signals over long distance makes it a great medium to provide connectivity to a user. Some common problems that the radio channel faces are fading, which causes the signal strength to decrease over long distances and when traveling through obstacles. Multipath propagation, which is a problem that arises when signals are reflecting off obstacles, causing the traveling path length to be different and a blurry signal when received at the destination end, and the interference of other transmissions and electromagnetic fields. Due to the above reasons, bit error rates will be a common problem when signals are carried in this way. These are the references my video is based on. Thanks for listening.